Hey everyone, my name is Dean Chessman, and today I'm going to show you how I made this motion-driven particle system in TouchDesigner. Alright, let's get started. So the first thing I'm going to do is bring in some video, and normally, if you're following along, you can just go in and add your video device in and add it in. But since I'm using my video in this corner here, I'm going to bring this element, my little cropped camera that I use for my tutorials. I'm going to start with that. So like this, could be replaced by any other video or your camera, your video device in what works well. I'm going to rename this null to video because I'm going to reference it more later. Another thing, I'm going to start making some constants. So I know I'm going to want some life frames, so how long I want each of my particles to live. I'm going to do that for 100 frames. I'm going to do a ratio, which is going to be based on my video null, and I want this to be referenced since I'm going to probably swap my video in and out here. So I'm going to do op video dot width divided by op video dot height. So that's going to get the ratio of what my video here is. Okay, cool. What else do I want? I know I'm going to have, let's go ahead and add our null. Let's add variables, keyboard in. I'm going to rename that to reset. I'm going to add a merge and merge these all together. And I know one more thing we're going to want is a dampen amount. So this is going to be to slow down my particles. Let's set this to like 0.98. Get to where we use that in a little bit. Okay, I'm going to right click on my variables, hit variables, and hit view. And let's move these up and out of the way. Let's move these over. And okay, what do we want to do next? So first I'm going to down res whatever my video is, because I'm going to create particles based on this pixel map here, so that they're evenly spaced out no matter what my resolution is. And I don't want it to be all of my pixels. Now my camera here is fairly small, so like we're only talking about 76,000 pixels right now. But if I go in and I add, an HD video or something like that, I don't want to have a particle for every pixel in that HD video. So I'm going to add this res here and go down to like a quarter. Now for this, it's going to make it nice and small, so 4690, but that's okay. We'll do it with this to start, and then we'll swap some videos out and we'll see what that looks like as we go on. Okay, so for my res 1, I want to make my starting points for my pixels, so I'm going to use my trick of using GLSL for this. And hopefully you've seen me do this before. If not, this is not scary as it seems, I promise. So what I want is just, I want to have, based on this input, a grid of values. For the red value, it's going to be the X value. The green value is going to be the Y value represented. So it'll be a nice gradient across the two of those. And the way I do that is in this GLSL DAT, I go in and I copy this little section here, vuv.st, and I put it at the beginning of this, then comma, 0, comma. So what that does is it gives me these coordinates in a perfect grid of XY locations of where I want my particles to start. So this particle in the top left will start in the top left. This particle in the bottom right will start in the bottom right in my kind of 0 to 1 mapping. Hopefully that makes sense. If not, maybe seeing as this thing goes what's happening, maybe that'll make more sense. I'm going to change the pixel value type here to just RGs because I'm not using the other channels. Okay, I'm going to look at my reference that I made this earlier so I don't waste too much time. All right, I'm going to add this to a null. I'm going to call that my start positions. And I know that is going to go into a feedback with a reset attached to that. Great. Okay, cool. Now let's create our life texture here. So we're going to go from our res into a noise, and we want to keep it the amplitude of 0.5, offset of 0.5, and I'm going to go to random. I'm going to make sure my output is just the noise. And yeah, okay. And so what I want this life to do is I want it to constantly kind of reset itself. This is going to be the starting position. It's going to be constantly added to. Each point is going to have a specific lifetime that, as it gets up to its full lifetime, which is going to be 1 in this instance, it'll then reset and go back to 0. So the way we're going to do that is put this noise into a feedback and then into a constant. And the constant, I'm going to change the output up here to be add. And then for the value of the constant, I'm going to do this life frame. So I'm going to drag it into my red value, and then I'm going to say 1 over that. So that means that every frame, I'm going to make these other values 0 just to make it clear. Every frame of feedback, I'm going to go through this constant. I'm going to add 1/100th to each value. Then I'm going to go into a limit, and I'm going to loop my limit so that if the values go above 1, they loop back to 0. I'm also going to go in and change all these to 32 float mono, because I only need the one channel. And let's see, what else am I not thinking about? I think that's good, actually. So let's just drag our limit back into our feedback, and you'll see. So we're constantly going in a circle. The constant's adding 1/100th to each value. If it goes above 1, then it's resetting back to 0, and we're just looping and looping and looping. And I'm going to add the reset here as well, just in case. And yeah, so that's going to be a null. I'm going to add a null on the end of that for life. And then I'm also going to use this to create a reset. So out of this constant, actually, after I've added to it, before I've added the loop, I'm going to go to the threshold, or add a threshold, and I'm going to say when it's greater than 1, or sorry, less than 1. So this is what this is showing, is every time the value goes above 1, which this limit is knocking it back to 0, this is going to be something I can use to reset my particle point back to its original spot. I'm going to do that by multiplying it by this start position. So I'll get to that in a minute. So I'm going to call that reset. Great. I'm going to line things up a little better here, so like kind of all my end values that I'm going to add together are close to the same place. Okay, what do I want to do next? Next, I'm going to add sort of my velocity and motion information to this. So I'm going to use one of my favorite tools here in the palette called Optical Flow. So I'm going to bring my video into my Optical Flow, and you'll see as I move around, the Optical Flow analyzes the previous frame with the current frame and tries to guess which direction that pixel is moving, and gives it a red-green value to represent the X and the Y value, and positive and negative to it estimates what the motion there is. And I'm going to use this to create an optical flow feedback loop. Let's get rid of this. And the way I do that, first I usually blur it, because the pixels are pretty like high at the main points of motion, so I want to spread those out a little bit. So first I blur it, and then I'm going to go from that blur into a feedback, and then the feedback into a displace, into both the displace. So I'm going to displace the input by itself, because the information coming into this is displacement data. So I'm using the red and green values from the actual optical flow to then push itself further. So the displace, I'm going to use the red and the green values. The midpoint is 0, and the displace weight, I want it to be pretty minor each frame, so 0.001. And that should be good. Then each frame, I'm going to blur it so that it kind of smooths out and has a liquidy effect. And then I'm also going to use a math to then kind of slowly fade it out as well. So I'm going to do multiply by 0.98 in a math. Get that away so you can see it. And then the very end, I'm going to add it to this original displacement amount. And then I'm going to bring that add into my feedback. So it might be a little hard to, oh no, you can see pretty well there. So now we can see this sort of fluidity motion happening. So I get trails going behind it. It's not like the harsh original input, you know, it's very flashy on and off, but I want to like kind of maintain the flow and the motion. So the particles, as they're moving through this, they pick up the motion that's kind of left behind by my trail. Okay, so let's add a null on the end of this and call it motion. And I'm actually gonna take all of these, I'm gonna right click and hit collapse, and I'm gonna say, rename the space to optical flow feedback, just to try to keep things clean. This network's gonna get a little messy, so I'm gonna try and keep it as clean as I can here. Okay, so now I have motion, I have particles, I have resets, I have life. I think it's probably good to start with. Okay, so every frame I want to take the position, which is going to be represented here by this feedback. I'm going to call this feedback position actually. And I want to add to it the motion from where that pixel is in space. So it starts, you know, right now it's actually reflecting directly like in this motion map, you know, where it starts out is the right point. But as soon as it starts moving, I need to actually reference from where it's moved to. And that's where the remap top comes in handy. So I'm going to remap this by using these UV values. Which is also nice because I'm not downrosing this motion, so it'll be nice, high quality, bigger motion input. But I'm only referencing the number of pixels that are in this this UV map here. Okay, so I'm going to make sure the image resolution is based on the UV input. And what next? Oh, I missed the important thing too. So I want the particles to retain, one of the big things about what we're going to do is we're going to retain the momentum from the particle. And so we're going to have to do that by making a feedback loop for the velocity as well, for this motion as well. So I'm going to start this with a feedback. Okay, so my motion goes into a feedback. That creates the first frame here, and then I also, let's see, what else am I going to do? So I'm going to have that feedback, and then every frame when it comes through, okay, no, I'm doing this wrong. Okay, so I actually want, all right, sorry about that confusion. So I do want every time to bring in this remapped motion. So that's what I'm going to add to the particles every frame. But you know, when it moves on and there's no current motion, I still want that particle to retain its momentum. So that's where the feedback is going to come in. I'm going to add it to this feedback. And I'm going to probably need to knock it down a bit because I don't want it to be equal amount of weight towards the new motion versus kind of its previous momentum. So I'm going to say like, let's knock it down like a tenth. And then let's add these together. Okay. And then another thing that I'm going to do is when I go back to my feedback, I want the particles to slow down. I don't want to just continually speed up and shoot off the side of the screen. I'm also going to add a dampening, which I already sort of alluded to earlier by adding this dampen constant. So I'm going to bring that in, and I might play with that value later. So I'm going to dampen it, and then I know I'm going to limit it as well. But let's get back to that later. So let's add a null and say to motion feedback. Okay, so let's bring that, attach that there. I'm also going to add a reset to my feedback. Great. Okay, so great. So now we've got our value here. This is what we're going to be adding to our position data here. So let's take this and let's add it to this value. And I know that one of the things I know is like this is telling me the motion. Well, actually, we'll get to that in a second. Sorry, I don't want to get too ahead of myself. So, all right, so I've got my feedback here. I'm adding my motion to it. Let's add this to a null called to position feedback and drag that back to this feedback. Okay, so we can see as we move, our pixels are moving their positions there. Great. What else? Okay, let's go ahead and make our instancing network so we can kind of see what the output is as we're tweaking things as well. So I'm going to do this with Circle Sop. Make it pretty small. Let's do open 05 to start. Let's just see what that gets us. Let's go into our geometry, or add that into our geometry. We're going to add a constant. We're going to add a camera. Oh, I forgot. Add this to geo, and then add a render. Now I want my render to be the same resolution as my video, so I'm going to go in here and say op video dot width, op, whoops, and reference our video operator again, dot height. Okay, and I'm also going to go and use a select here and select my video. So I'm going to add these over the top of each other soon. Okay, let's finish our instancing here. Let's go to the geo, turn on instancing. Let's add in our instancing top, RG and B. Okay, looks crazy. Okay, we're gonna have some dampening to do here soon. Let's see, what should we do first? First, let's fix our camera. Let's go to the camera view, make it orthographic, say bottom left. And then we want to bring in our ratio for the ortho width. We also need to make sure, let's actually, I forgot a step here. So from the position feedback null, I want to make a different position null actually, and that's what I want to reference here in my instancing because I need to adapt for the ratio. So I'm going to take in my math here and in my range, I'm going to say for the red range, I'm going to go, instead of from 0 to 1, I'm going to go 0 to the ratio. So this should match up to what we're doing. Okay, what else do we need to do? Another thing I know I need to do is I'm going to select this res. And I'm going to bring it kind of closer to the end here. Because in the end, this res is what I'm going to use for my color for the pixels, because this resolution has the same number of pixels as my position does. If I had brought wait, does it have the same amount? I messed up something somewhere. I'm gonna have to fix that. I'll find it. Okay, so let's see. If I drag it in, you'll see my problem here. So if I bring in my null one for my, oh, this is color. You have to update the reference. Okay, so my color reference, and I'm getting that error. I'm saying all ops must generate the same number of instances. So I messed up somewhere, and I likely here. So yeah, so in my remap, let's see, I'm adding something here. This feedback is likely the culprit. Or this math, let's see. So I need to make sure that this is the same. Oh, let's see. So this needs to be the same number of pixels. Okay, this add is where we're gonna, there we go. So that input needs to, perfect. So what happened was when I was adding my motion data from my remap motion data to my kind of initial motion data, it was using the input one, and this is actually a great reminder that I probably should use this, is what I should do instead of having this full resolution. I want to have the UV mapped resolution because that'll use this in the first frame. It'll use this UV map to create my initial feedback frame. Okay, let's see how that's looking. Now I'm at least getting some face explosion here. Let's go ahead and add this render to an out top, and then right click and hit view. Bring that up to my corner here so I can preview what I'm doing as I'm doing it. So as I hit one, things are going off. So one thing I haven't done yet is used my reset. So the way I'm going to do that is I'm going to take my start position. I'm going to go to multiply. If I can catch the right thing. Multiply by my start position. Let's Let's make sure it's full. Oh, I missed. I need to make sure this threshold first. So threshold, since this is just a 32-bit mono right now, but as it gets to the threshold, I want to add an alpha channel. So I'm going to do mono plus alpha here. And then in the multiply, I'm going to go up to a full 32-bit RGBA. Okay, so what's happening here is as they hit the threshold, I'm going to reset it to their start positions. And I'm going to do that with an over top here after my feedback. So replace some things here. Now we'll see, I don't have to hit 1 anymore. It automatically just resets particles. Okay, so obviously my motion right now is pushing way too hard. There's a couple places I could do this. I could add a math here, or I could go into my optical flow and bring in that force, or bring down that force, so like the input value could be lower. And one thing you'll notice here, if you look it down next to my camera, it's moving the wrong direction. Like my optical flow is pushing pixels the opposite way I want them to go. So let's do that. Before we add it here, let's invert it. We could just subtract, but I'm gonna do this math here. So if I had a math, go into my multi-add and hit -1. So now when I go left and right, it reflects the right way I want to go. Okay, let's go ahead and add this these pixels over the top of my final render here. So let's do an over. Cool. Okay, let's see, what else can we add in here? Maybe we dampen a little more. So let's like go to like 90% dampen. So now we get it kind of stops. Cool. All right, so what else could we do here? Let's bring in some other videos and see what that looks like. So just go to my Finder here, and I've got some different videos. So like if I bring in this guy, he's like 4K, so I'm going to definitely render, or I'm going to slow him down, or down res him a little bit. So let's do like a half res. And if I bring him in as the video, hit 1, so now we see has these really cool kind of particles shooting out from where he comes in. Let's bring in another one so we can get more. So here's like another like kind of dancey one. So I have to hit 1 to like start seeing the results of this. One thing I want to is right now the color is actually always updating. What I'd like is instead is to have the color kind of stay the same throughout its life cycle. So as the new particle resets, I want the color to stick until it resets again. So let's do that here. We've got our select here already, but let's put that into a feedback. And let's also select our reset null. And then let's multiply these two together. And then put this over. And let's feed that back into itself, and then have that be our color output. So now the color will stick. You know, if the particle started from one of these like sparks, it'll stay white until it dies out, which I think gives it a cooler effect, because then it's not kind of flickering on and off, kind of white to black and white, whatever, you know, as the original pixel that it's referencing changes. So you know, there's some other cool things with this, like, you know, really with like a big interactive installation, you know, if you just render the particles, like this is just rendering the particles, you get kind of that cool just the motion effect coming out. So if you had a camera input, you know, you could have people kind of change particles. You could have the color reference be something completely different and have people kind of, you know, move their arms around to wash away, or to kind of, you know, move the particles around on whatever image you have there. Let's see, let me think if there's anything else I was going to add to this. I think I'll leave it at this, and let you guys, if you follow along, play around with it and try things out. If you do make something with it and post it online, definitely tag me. I'll reshare anything anybody tags me in that they made for my tutorials. I love seeing it. And if you want this project file, it will be available to my Patreon followers. If you look in the links down below, you'll find that. Also, just some information about me. I am a freelance TouchDesigner developer. And if you have a project that's similar to this or really anything else, I'm happy to chat with you. Would love to talk about any projects you might have that you would want to work together on. And I think I'll leave it at that. We will see you in the next one. Thanks so much.